Welcome back, Mustangs, to another edition of No Hair, No Problem. Today we're representing my daughter's hat, Taylor Swift, for her love for Taylor Swift. And then I got the white shirt on for our whiteout that we're going to be doing this week here for Homecoming Week. But, I feel like I never get a chance to share much about myself, some history of myself. So I wanted to share something with you. I actually used to work for the circus. Told true story here. I used to be their human cannonball until they fired me. Yeah. Anyways, so today in this lesson, we're going to be working on Unit 2.4, which is complex numbers. And in this section, we're talking about imaginary numbers and real numbers, which combine to make complex numbers. We're going to be using this more with our unit with polynomials because we've been talking about when we look at graphs, how there's real solutions that we can see where it actually hits the x-axis. And then we're going to talk about what it looks like when we are supposed to have like 4 or 5 answers, but we don't see all the answers. That's where we end up with those imaginary answers or the complex answers, okay? So let's get started. This should be a real quick review because we actually did complex numbers in our first unit. So we're just reviewing this again. So let's get going on it, all right? So again, to reiterate the idea of what imaginary units are, each complex number can be written in the standard form, and that form is that a plus bi. And so, for instance, the standard form, when we have complex number square root of negative 9 minus 5, well, that's square root of negative 9. We can't take the square root of a negative. And so what we end up doing is we say it's that, if you remember, that negative inside is the same as an I squared, and then minus 5. If we take the square root of 9 and the square root of I squared, we just simply end up with 3i minus 5. So the correct form when we're looking at this says that we put the a value first, which is the real value, and then we put the b value second, which is the imaginary value. And that's the standard form when we're looking at these. So rearrange it, we'll have our a plus b, whoops, that's our a plus bi form going on right here. And if I was to say, what's the a value? You'd say it's negative 5. What's the b value? It's positive 3. Okay. So in the standard form, the real number, as I said, the a value is called the real part of this, and that b portion of this is called the imaginary part of this. And together, the real and the imaginary make what we call a complex number. Try to imagine if you had a friend that was, had real friends and they have imaginary friends, you'd probably say that they were kind of a complex person to know, right? Am I right? All right. So anyways, the equality of complex numbers says that if I have an imaginary number, and a complex number, and it's equal to another complex number, what we can do is we can look at this and say, well, the a value, which is my real parts, is going to equal to my c value, which is the real part as well. And then we can say that the b portion of this and the d portion of this, which are both the complex parts of this, the imaginary parts of this, these two would be equal to each other. So the real would be equal to the real, the imaginary would be equal to imaginary. Now, what are we talking about here? Well, when you look at a big, crazy problem like this, it's a matter of lining up everything that belongs together and putting the other stuff that doesn't, let me restate that. Put the imaginary stuff together, put the real stuff together, and solve for those parts. Now, I'm going to try to color code this so it looks and jumps out at you, okay? This portion right here, it doesn't have any i's attached to it. And because it doesn't have any i's attached to it, this is my a portion that's going on here. And when we look at this negative 11, that doesn't have any i's attached to it. So we'll call this also the a portion of the right side there. So if we take these two parts and we put these together, we're going to say that 4 plus x is going to equal negative 11, which means that if we solve, we get x is equal to negative 15. Okay. And then let's look at the complex parts of this, or the imaginary parts. I keep saying the wrong thing there. The imaginary part here is this negative 2yi, and then the positive 6i. Those are both the imaginary parts. And so let's take those parts and name those as our b values. Now, again, I don't need to worry about the i's. We can just focus on this portion right here and this portion right here. Those two parts are supposed to be exactly the same if we're going to have the left side equal to the right side. So in order to do that, then it's just simply negative 2y is going to equal our 6th. That means that y would equal negative 3 here. That's it. That's how simple these problems are, okay? All right, so imaginary units. As I just said, this just summarizes it for us that real numbers and imaginary numbers together, so we've got the a value and the bi values together will make that a plus bi portion that we were talking about. Okay? And so when we're talking about operations with complex numbers, they're not actually complicated at all. When we take the a and the b values and we put them together, all the a values, the real parts, are always going to go together. And then all the imaginary parts, those b values, will go together as well. What are we talking about here? Well, let's take a look at some basic general operation problems here, okay? Take a look at the first one right here. Treat the I like it's an x. The only time the I really changes anything is if we have like square roots with negatives or if there's I squares. But for adding and subtracting, it's pretty straightforward. What we have is a 3 and a 2 are going to go together. And we're going to be doing 3 plus 2, which will simply add up to 5. And then we're going to look at the negative I and the positive 3i. And those parts together will just be negative I plus 3i, which together will be positive 2i. Okay, so we got the a portion, which is the real, and 2, which is the imaginary, and I. And overall, we've got our complex number, okay? Let's continue with this. I'm going to get away from color coding just because these should be pretty straightforward. So we're going to have 1 minus 4, okay, which is going to give us a negative 3. And then we're going to go ahead and do 2i minus 2i. So 2i minus a 2i is going to leave us with 0. So we're going to simply be left with a negative 3 for this. Okay, let's carry on here. All right, so this one, we're going to have a 3. Now this minus is going to get distributed out here. So I'm going to actually write all this out. We're going to have 3 plus 2 minus 3i plus negative 5 plus I. Okay. Put all the real stuff together. That's the stuff that doesn't have the i's. And what we're going to have here is 3 plus 2, which is 5, minus 5, which is going to equal 0. So then what's going to happen is all of those real parts are just going to cancel themselves out. And let's go on to the i's. We have a negative 3i and a positive 1i. We have together a negative 2i. Okay. All right, one more. Don't get bogged down by all the operations here. It's pretty straightforward. All right, so we got 3 plus 2i plus 4 minus I. Now don't forget to distribute the minus. That's right there. We're going to have a negative 7 minus I. And when we go to combine these, real parts come first. So we're going to say 3 plus 4, which is 7, minus 7, which is going to equal a 0. Okay, so we don't have any real parts. Let's look at the imaginaries now. Let's get rid of those first. And then let's look at the imaginary. So we're going to have 2 i's. We're going to take away the 2 of the i's. So we have just 1 I. And we take another I away. We have nothing. So my overall answer for this is just going to equal a 0 here. Okay. Now, what about when we're trying to perform operations and we try to write the result in standard form? Well, let me jump forward here a second before we do stuff, operations. Okay. Actually, no, we can do this. We'll jump forward to something in a second when we get down to letter E, okay? So with operational stuff, it's just like when we have an X, we go ahead and treat it like we're just doing simple FOIL or, just distributing out, okay? And so distribute this out, we're going to have an 8 plus 6i, okay? We'll distribute this out, we're going to have a negative 4i and then a negative 3i squared. All right, and if you recall when we did these, that the 8 just comes straight down, this is 2i, but then the one that changes is this guy right here. If you remember that I squared is the same as saying negative 1, so this is like saying negative 3 times negative 1, which just turns that into a positive 3. Whoops, I don't know what just happened there. All right, and then just put our stuff together that belongs together. So 8 and 3 are both the real parts. Let's put those together. We get an 11, and then we have that 2i remaining. So we're stuck with 11 plus 2i. All right, let's go to the next one. Same idea. Now I want you to notice something unique about this one. These two are conjugates. We've talked about these before. When you have the same value for the first portion, you have the same value for the second portion, and then we have a plus and a minus in the middle. These are conjugates of each other. So watch what happens when we multiply conjugates together. 3 and 2, that's going to give us 9 minus 6i. 2i, and that's going to give us a positive 6i. And then we get a minus 4i squared. Put these together, we have a 9. Those cancel. This right here, that I squared is a negative, so that's going to turn it into a positive 4. And we simply end up with a 13 for the overall answer here. Okay? And so whenever we have conjugates, the shortcut that I've said in the past that I like to do is I just take this value and square it, and I take that value and square it. So really it just becomes 9 and 4 and just add them together. The rationale is that the conjugates will eliminate the imaginary parts, and we should only be left with a real answer in the end. Okay? All right, let's go ahead and look at letter C. We'll distribute this out. Distribute. We have a negative 4i, and then we have a positive 20i squared. All right, that I squared will turn this into a negative 20, and then we have a minus 4i. So you'll notice in this one that I actually took and rearranged it to put the negative 20 in the front and then the I second. And that's because if you recall, it's supposed to be A plus BI for the overall answer here. I don't believe WebAssign will accept answers if it's not written in that A plus BI form. Okay, so make sure you're aware of which part comes first when you're writing them. All right, letter D. Okay, we're going to do a common mistake first. Okay, this is not going to equal. This is a common mistake. I bet you can figure out what I'm going to do. Most people will take this into squared and say it's 9 plus 4i squared. And therefore, it's not equal to 9 minus 4, which is not equal to 5. So this is a common mistake when people see a square right there. The reality of it is that what you're supposed to do is remember that this is being written not once, but twice. So really what's happening is we're going to have 3 plus 2i times the 3 plus 2i. And if we go through and distribute this out, we're going to end up with a 9 plus 6i. And then we're going to distribute the 2i out. We're going to have a 6i plus 4i squared. And we end up with a 9 plus 12i. This turns into a minus 4. And then we end up with a 5 plus 12i. Okay? So very, very, very big difference between if I just squared the first and squared the second versus if I actually take and write it out and distribute it. Okay? So let's jump to this problem here. Most people will take this and try to throw these directly into a calculator. If you actually look at like the next ones here, jumping ahead, and we'll come back in a second here. Where did it go? Like when you look at these right here, I took these and I put them in the calculator just so you could see what ends up happening and limitations that we have in Desmos. So you'll notice here that when we take the square root of negative 3 and the square root of negative 12 and put those in the calculator, we get an undefined answer, and that's because it's an imaginary answer. Well, that seems kind of stinky. That what ends up happening is on these calculators, on the Desmos calculator, there's a limitation where it can't do imaginary numbers. Desmos is aware of it. It's been on like the couple years now, it's been like this where they know it, but they haven't done anything to do any updates with it. So normally I'm like a big fanboy of imaginaries, or I'm sorry, a big fanboy of Desmos, but this is a big restriction and therefore we can't use it. But that's okay. We don't really need it. We can do all this stuff by hand, okay? So let's jump back to the problems that we were just doing here. All right, we'll get back to all that stuff in a moment, but let's get back to this right here. Okay, let's distribute this out and watch what ends up happening here. 3 plus, I feel like the notes are not in like the best order here because of this. But when I distribute this, we're going to get 15, and then we get plus. Let's distribute this here. We're going to have, not plus, minus, sorry. Ugh, hot mess. All right, we're going to have this right here will give me a negative 3 square root of negative 6. Okay. We'll distribute this part. We're going to end up with a 5 square root of negative 8. And then for the last part, we're going to have a square root of, and now this is the part that I want you guys to be aware of. Most people will take this and simply put this together and say, oh, I know in the past that if I took square roots, I could just multiply them together. Like I could say the square root of 4 times the square root of 9 is going to equal the square root of 36, which just equals 6. And I could just multiply those together. And that seems all true because 2 times 3 does in fact equal 6. Well, this is not the case when we're dealing with imaginaries. Okay, when we're dealing with imaginary values, you can't just simply multiply them together. Because what happens is I have -8 here and then -6. Well, if I just multiply them together, we get the square root of 48. Well, where do my imaginary stuff go? You can't just get rid of the imaginary part of this. So this is actually completely wrong. This is a very, very common mistake that people make. Let's not do that. Instead, here's how we're supposed to actually approach this. This square root of -8 is actually square root of 8, but with an I on the outside. And that square root of -6, I'm sorry, is actually square root of 6 with an I on the outside. Now we can put these together. Now we can go ahead and actually multiply this out. So if we multiply this out, what we end up with is the square root of 8i times the square root of 6i, and both of those i's are outside of the square roots. And what we're going to end up with is the square root of 48 with an I squared on the outside. And what's going to end up happening is this is going to make it a negative square root of 48. Okay, so that ultimately changes our sign of this problem from a plus into a, from a minus into a plus in that part. And now we're left with that 48 that's there. Okay, so there's a big sign change that actually takes place because of this. All right, let's continue. Now that we've done that, let's continue with solving this. This is going to be 15 minus 3 root 6i. This will be 5 root 8i plus root 48. Okay, now we're going to clean up these square roots because they can actually be reduced. So if we clean up these square roots, we're going to have 3 root 6i. Then we're going to have 5. This 8 right here is going to turn into a 2 root 2i. And then that 48 is going to turn into a 4 root 3. Again, that 8, that's because factors of 8 are 4 and 2. So the square root of 4 is just 2. That's where that 2 on the outside comes from. And then the factors of 48 are 16 and 3. And the square root of 16 is that 4. Okay. So again, this is 16 and 3. Square root of 16 is just that 4 that we have there. All right, so now everything is in its simplest form. Let's get this into that correct a plus bi form. And this is the hardest part of this, in my opinion. All of the stuff that's together that does not have an I will go together. So the parts that don't have an I, these are going to be the real parts. So these parts right here do not have an I. Those will get clumped together and become my real part. That's the 15 plus 4 root 3. This is my A value here. Okay, it's a decimal. For my B value for this is the imaginary stuff when you put it together. So this right here being the imaginary parts, we're going to go ahead and put those together. I'm going to go ahead and put plus, and we're going to actually take the I out of it. And we're going to have a 10 root 2. That's from this first part up here. And then we're going to have a minus 3 root 6. And so this portion right here is my B. So the A value in this is that 15 plus 4 root 3. And the B value in this is the 10 root 2 plus 3 root 6. And then I. Okay, it doesn't matter that it's not like actually put together into a decimal. This is the exact answer of this. Okay. All right. Tricky. Next one, we're talking about conjugates. So we talked earlier about conjugates, how they will actually negate one another. And if you recall, what is the conjugate of these? You keep the exact same value for the first part. You keep the exact same value for the second part, but you take the opposite of the middle of these. When you multiply these together, we're going to get 1 minus I plus I minus an I squared. And we'll end up with a 1. Those cancel. This turns into a plus 1, so we have plus 1. That means that this is equal to 2. Okay. And again, simply if I did this, I would go 1 squared plus 1 squared, which just gives us 1 plus 1, which is just 2. All right. Watch my shortcut here. I'll do it again. 4 squared is 16. 3 squared is 9. Together, this is going to equal 25 when I take the conjugate. Watch the conjugate in action here. We're going to go 4 plus 3i. That means we're going to have a 16 plus 12i minus a 12i and then minus a 9i squared. Okay. These cancel. This will turn into a plus 9. So we simply have 25 for the overall answer when we use the conjugate, which is consistent with what I said up there. All right. All right, let's get to some other fun operations with complex. So when we're doing, when we have a fraction, we never want to have an imaginary part in the denominator. That's just good practice not to have any irrational parts or imaginary parts in the denominators. So how do we clear that up? This is where we use the conjugate. All right. So the conjugate of the denominator, not the numerator, of the denominator of this is going to be 4 plus 2i. And whatever we do to the bottom, we have to do the same thing to the top. Okay. Now for the bottom, we can keep this real quick and simple. 4 squared is 16. 2 squared is 4. That's going to equal 20 for the denominator when we just simply add that together. Okay. For the numerator, a little bit more work. When we multiply this out, we're going to have an 8 plus 4i plus 12i plus 6i squared. That plus 6i squared is going to turn into a minus. So we're going to have 8 minus 6, which is 2. And then we're going to have 4 plus 12, which is 16i. Now, all of our answers have to be in the a plus bi form whenever we're doing these imaginary answers or these complex answers. So now these are two separate fractions. You get 2 over 20 plus the other fraction here we get is 16 over 20, and then we get an I. So let's reduce these fractions. We have 1 over 10 plus 4 over 5. That's a 4. I don't know what happened there. I. So my A value for this is 1/10. My B value for this is 4/5. Okay. All right. Let's jump down here. Some operational stuff. Principal square root of, this seems backwards that we're doing this now because we already talked about this, but the square root of -3 is just going to be square root of 3i. I do want to take a moment to recognize that a lot of you guys, as we talked about in the past, like to write the I in the front. I don't think WebAssign accepts that answer. You do have to put the I at the end. And so while I like that personally, I don't think it's allowed that you put the I in front of the square root. You also want to be sure that you don't do this, that you don't have the I still inside the square root, okay? You want to keep the square root separate from the I, keep the I off to the right of it, okay? All right, so let's do some operational things. Remember we said, okay, whoops, that's not the word recall. Recall that we cannot do square root of -3 times the square root of -12, okay? It does not equal the square root of 36, okay? So just keep that note to yourself. Don't forget that. You can't simply do that because that gets rid of the square root or the imaginary part altogether. Let's do what we're actually supposed to do. That square root of 3 is actually square root of 3i because that negative is just an I on the outside. That square root of 12 is just a square root of, the -12 is just a square root of 12 with an I on the outside. So then we have the square root of 36i squared, which will turn into just a 6i for the overall answer here. Okay. All right, let's look at this one here. We're going to simplify these. So we're going to have a -16 times 3 minus a -9 times 3. This is going to be equaling 4 root 3i. This will end up equaling 3 root 3i. And then we could put these together. 4 root 3's minus 3 root 3's equals just one of those root 3i's. Okay. One more question here. We got -1 plus, I'm going to make the change right now. It's going to be root 3i squared. That negative just goes outside to become an I. That square, again, implies that we're going to take this and multiply it by itself. So we're going to have -1 plus root 3i. Let's go ahead and multiply this whole thing out. They're not conjugates, so be careful here. When we know they're not conjugates because these are not opposite one another. Let's continue multiplying. So we're going to have 1 minus a root 3i, and then minus another root 3i, and then plus a root 9i squared. So we're going to have 1 minus 2 root 3's, because there's 2 of them there, I. This whole thing right here is just going to be a -3, because that I squared is a negative, so this will be a -3. And so we're going to have a -2 minus 2 root 3 I for the overall answer here. Okay. All right. So, what is it that we're actually doing, and why are we doing these? Well, this is the connection now back to what we've been talking about when we're trying to solve. When we solve these, we're told that that degree right there tells us that there are supposed to be two answers for this problem. And when we look at the picture of this right here, that x squared plus 4, look at how many times this hits the x-axis. It never hits the x-axis. It literally only hits the y-axis here. That's because this is a quadratic that's been shifted up 4. But it's supposed to have two answers. And when I look at this, there aren't two answers. At least there's not two real answers. If they were real answers, we would see them hitting the x-axis. So that tells us that since there's no x-axis intersection, that there's no real solutions, that there's only imaginary solutions. So what does this look like then? Well, we can use our basic methods. In this case, I'm going to use square root to solve this. And if I take the square root of this, we're going to get that x is going to equal plus or minus 2i. Okay. To verify this, I'm going to actually work backwards. If I know that x is equal to 2i, and I know that x is equal to negative 2i, that means the factor for this is x minus 2i is equal to 0, and x plus 2i is equal to 0. And then if I were to take and put these together and multiply them, x minus 2i times x plus 2i is going to equal 0. That means we're going to have an x squared, a positive 2xi, a negative 2xi, and then a negative 4i squared. And if I simplify this, this gives me x squared, those cancel, this turns into a plus 4, that's equal to 0, and it is the exact same thing as what we originally started with to confirm my answer. Okay? So we get two imaginary answers, two complex answers, no real answers. What about this 3x squared minus 2x plus 5? Well, you would sit here and try to factor this. You would do guess and check and realize, oh, I can't factor this. It's not factorable. Why isn't it factorable? Well, that's because when I look at the picture for this doesn't hit the x-axis. And because it doesn't hit the x-axis, there's no real solutions. And so the next thing you do is go, well, how do I solve this? Okay, I could complete the square, which is a terrible idea here. So then we just end up using the quadratic formula. Well, it's not pretty, but it's math, and we could do it. Negative 2, so the opposite of b is 2, plus or minus the square root of b squared, minus 4 times a times b. 4 times a times c, not b, sorry. All over 2 times a, which is 2 times 3. So that means that we're going to have x is equal to 2 plus or minus the square root of. This will be 4 minus, and we're going to get a big number here. This is going to be 4 minus 60, which is going to be a negative 56 all over 6. And that means we're going to have x is equal to 2 plus or minus. I'm going to take and we're going to simplify that root 56. That root 56 can be broken into a 4 and a 16. Nope, 4 and a 14, sorry. That means that that would equal to 2 root 14. So I'm going to make this 2 root 14. And that negative that we had there is just going to go outside as an I all over 6. And now let's get into that correct a plus bi form. We're going to have that 2 over 6 plus or minus 2 root 14 over 6i. And then we'll finish simplifying. We end up with 2 over 6, which is 1 over 3, plus or minus root 14 over 3, because the 2 and the 6 will reduce. And then we have I. This is my A, this is my B. There you go. So while the name complex numbers, it sounds like it's actually complicated. It's all basic algebra that you guys are used to at this point. It's just a higher level of thinking. This is going to come into play, though, when we start doing our next section, which is dealing with the fundamental polynomial problems, where we've got higher degree problems that have real solutions, and we've got higher degree problems that have imaginary solutions, and then we're going to have problems that have both solutions, okay? So you guys take care of each other. Be safe, be respectable, be responsible. Reach out if you ever need anything. Like and subscribe. Take care and have a good one.